Hi, good day. We've now come to lecture number 11. And this lecture involves analysis at upper level, and it's a vector analysis. And this vector analysis involves streamline analysis at 850 hectopascal level for Africa and Europe. This analysis will be carried out, or will be shown to be carried out in two phases. That's for North Africa and Europe, and then for Western North Africa. This is the map of 850 hectopascal streamline analysis for Africa and Europe, and there at 27th February 2013 at 12 GMT. And as you can see, the map is of a low resolution, so we decided to crop it, and we have down two maps, North Africa and Europe, and then Western North Africa. Now, this is the map of the cropped map for North Africa and Europe on the 27th February 2013 at 12 GMT, where we have carried out streamlines, and I'm guiding us on this analysis. This already analyzed streamline analysis. And what is streamline? As I said earlier, streamline is a line drawn parallel or tangential to the instantaneous wind velocity. Streamlines are lines drawn parallel or tangential to the instantaneous wind velocity. Now, looking at the map, you see various winds scattered everywhere at various stations, station circle. You see the direction and you see the speed. For example, for this one, look at my cursor. This is station circle. This wind and the direction tensor is coming from around north of northwest, and then this protuberances, these lines drawn out from the line, that is the direction, is the magnitude, that is 30 knots. But we're not dealing with the magnitude but the direction in the streamline analysis. So in carrying out this, we start from here. Now we draw line parallel to this wind and then turn it around as if it's a westerly wind and put our arrow. And it's because of this wind here that is westerly. So it will come like that and turn like that and arrow there. Then the next one we follow the same way, that way. This one we follow the same way and that way. Arrow put there. We come here again. That's another wind that is coming almost like from the north. It comes down south and then turns around again, becoming a westerly here. We go to this one likewise. We take it from here and then southern, down south, passing through two stations, and then of course parallel to them. Then here it turns around. This is a northwesterly wind and it turns, and then here becoming a westerly. The arrow is put there. This one is underlined, not so visible, but it's there. Underline drawn parallel to the wind here, and then parallel to these two wind, and then arrow put there. Then we take it down like that, and then to this point. Then this one again is another line drawn. We take it parallel to this wind direction, which is almost northwesterly wind. Then this is the arrow there. Then we take this thing through here, parallel to these two stations, the direction of these two stations, and take it straight down to this place. And here there is a wind indicating that's like almost a northerly wind, not northwest, not northeast, north of northeast. So we take it down, and this becomes an asymptote of divergence. And then here it turns around because there's a westerly wind here. It curves again to this side. And now we take this other one, this one from here. We take it parallel to this and then go southwards. And here we look at this again. It has to be parallel. We take it down like that. And then we turn around here because the wind is telling us it's from northeast here. So we have to turn around and then continue like that. And over here again, we see the wind becoming almost like a west or southwest. And we turn around like that and follow it to this place. And then here, we draw a circular thing will exist here. And we put an arrow giving us indication there's a cyclone here. Now, we continue here and take this direction, pass like that. Then over here, it branches this way because of these winds here, and there's another wind here, and therefore it will branch following here. This one will branch following here and then go like that, turn around, and there. Another one will branch out like that because of winds that are here, turning around and then going there here, diverging, asymptote of divergence, and then over there. The arrows have been put in place. Then we come to this side of it that branched out. It continues this way, and here it branches out again this way. Another one coming through the center, another one this way because of this wind here. So this is becoming an asymptote of divergence, and like that. Then looking at here, this one continues this way, this one this way, and if you look at southern part of it, wind is coming almost like a southeasterly, then turning around like that towards almost a westerly. This one almost going the southerly, north. So here is asymptote of divergence, and here also asymptote of divergence, but here asymptote of convergence because they are converging here, and here also convergent, asymptote of convergence. That is to say, the wind comes from this way up, and then from this way down, entering, and then goes out this way and that way. And this is what we know as our neutral point. The wind continues here and then turns around in an anti-clockwise fashion, and then goes round to this, becoming like almost a circle. So a C is put here telling us it is a cyclone. Then this other one is also taken, entering here to become an asymptote of convergence, and here likewise entering there, and this one as well going in here, and this following this one parallel and then going in into this place, and this one this way, then this one turning like that. And then over here we have this direction that has branched out, continue like that. The issue here is we draw the lines parallel all the time, parallel to the wind. We ensure that it's parallel to the wind, then we turn it around like that, and then to this point. And now for the next one, this is the one that comes out from here, from that neutral point area. Then we go straight, parallel to this wind, and then parallel to that. But here there's a wind that is telling us it's almost like a southwest. We turn that direction again in respect of this, and then go around this way almost like a westerly. And the same thing happens here. We turn it around like that. Another one's joining, forming an asymptote of convergence. And since the flow direction is almost clockwise, this is an A, anticyclone. Then coming to this top left-hand side, we have this following the same direction of the wind, like that, and like that, and like that. Right? And then this one, the same thing. We follow this way, like that, and then like that. Ensuring that we are at the station circle, we draw the thing parallel to the direction of the wind, and over there. And then this one turns like that. So we are seeing clockwise turning of the wind, and that gives us, that tells us it's an anticyclone. So here we have cyclone, and here anticyclone, and here cyclone, and here anticyclone. So this is how this analysis is carried out, the streamline analysis. Remember, for streamline analysis, you draw lines that are parallel or tangential to the instantaneous wind velocity, and you endeavor to follow this as long as you come to the station. You don't cross the wind direction. You have to go parallel to the wind direction, ensuring that it's parallel. At every stage where it requires bending, you bend, and so on, until you get to the right place. And it's essential you put the arrows in this streamline analysis. And of course, remember, when winds are like this one here, it tells us that the wind is coming from here and not going this direction. The wind is coming from here and going this direction. That's what we know. So at this juncture, I will be bringing this lecture to an end. The next one will now involve West and North Africa streamline analysis at the same level. Thank you very much.